Hello, my name is Jon Holmes and I'm CEO and co-founder of Microneedle Diagnostics, the manufacturer of VivoSight OCT skin imaging systems. In this series of talks, I'm going to explain how OCT can be used in microneedle array patch research. In more detail, I'll introduce OCT skin imaging and VivoSight to microneedle array patch researchers and show some specific details of what you can do with VivoSight in terms of making actual measurements of structural details like the microneedle penetration depth and the dynamics of the needle post-insertion, and also of the impact on the skin after patch removal, such as quantifying the resulting erythema. In the middle of this slide here, you can see the VivoSight OCT system. It has a handheld probe, which is shown here, installed on its holster, and a display which shows you the scanned image in real time. Bottom right here, you can see that I'm just scanning this subject's cheek. And at top right, we also have a 3-axis stage for mounting the probe in a temporary manner just for ex vivo measurements of samples. So what is OCT exactly? Well, it's a way of building up an image of subsurface tissue. What we do is we put a laser beam into the tissue. Most of the light gets scattered and it's no use for imaging, but some lucky photons make it back without being scattered, and those are the ones that we detect with OCT to build up our image. It's a bit like seeing through fog. On the right here, you can see a comparison of images taken with of the fingernail bed with MRI, with ultrasound, and with VivoSight OCT. I'm sure you can see that the VivoSight OCT image is way more detailed. You can actually see the epidermis, you can see the nail plate here, and the subnail matrix. The VivoSight OCT probe rapidly scans a patch of skin 6mm by 6mm, capturing OCT images as it goes. In this way, it builds up a 3D image stack of OCT data which can be viewed in any direction you wish at a later date. Great, so that's how OCT works. What about imaging and measuring microneedle array patches? Well, a really useful thing is that we use infrared light in VivoSight, so we can see clean through a polymer substrate, just like this one shown here. And so we can actually see the microneedles embedded in the tissue. And we can see the tissue around it. VivoSight OCT resolution is better than 10 microns, which is easily small enough to see the details of individual microneedles. In fact, the pixels are only 4.4 microns across. With high resolution capturing of image stacks, we can really look at the details of the microneedle array patch before insertion, as shown here. We can measure the width of the microneedles and the length, and you can check these parameters across the whole microneedle array for uniformity. I'd like to thank the support of Dr. Enrico Laranetta and Professor Ryan Donnelly, who provided the microneedle array patches that we used in this sequence of images. Now, since we can image in vivo, we can measure in vivo. We can make measurements of key microneedle parameters, such as the diameter, the penetration depth of the needles into the tissue, and the pore diameter, the diameters of the holes that are created, the size of the air gap, and also the dissolution and swelling behavior of polymers that are designed to hydrate in vivo. All this can be done on a time-based series. We can actually monitor the behavior post-insertion over a period of time. And this is really, really important for microneedle characterization and for optimizing the design. How well do the needles penetrate? Do they penetrate to the right level? Do they deliver the drug in the way that's been designed or anticipated? And after removal, we can also look at the skin recovery. These are all key parameters for microneedle design that OCT imaging gives you a key insight into. Now remember that OCT captures a whole stack of individual OCT images across the MAP array. So we can pick out individual needles and focus in on them and measure exactly what is happening to them during the period post-insertion. We can measure the penetration depth very, very precisely and the size of the air gap. And we can do that over a period of time. In fact, this sequence here was captured over a 60-minute period. We're just looking at 3 microneedles. And you can see that the microneedles have turned to, let me just run that again. In it, you can just see the sharp microneedles starting to dissolve and turn into a black color as they hydrate. You can also see the air gap shrinking. I'll run that one more time. Immediately post-insertion, we have a large air gap. We have pointed needles, and here they are steadily dissolving and swelling. And then we can map that and show that on a chart. So here we are, this is the time after insertion. And this is the length. So we have 2 lines here. One shows the total needle length, and you can see that over a period of about 20 minutes it shrinks, and that's corresponding to the needle becoming more and more blunt. And then the total insertion depth, also that shrinks a little and stabilizes, and the gap between them is the air gap. Pore size, initially it goes up to about 280 microns, and then it gently reduces over a period of time as the needle dissolves. And finally, this chart here shows the proportional percentage of the microneedle which is hydrated. So it starts off with 0, and then you can see here that the needle is starting to hydrate and turn to a black, a material that appears black in the image. And after 60 minutes, it's fully hydrated, and the hydration is starting to penetrate into the substrate. And we can track that over a period of time by looking at taking repeated scans. So this particular microneedle array took just over 45 minutes to completely hydrate in a linear fashion. And this sequence of images taken, this is actually of a different microneedle array which dissolve rather more rapidly, and you can see the change in the microneedles, immediate blunting, and in fact just after 20 minutes the hydration process was penetrating deep into the substrate, and the microneedles have become very, very broadened. So this really means that OCT gives you a way to actually measure and monitor the morphology of microneedles post-insertion. It gives you a way to look at how that can be affected by materials, spacing of microneedles, length of microneedles, and so forth, and make rapid progress on optimizing the design of your microneedle arrays.